Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 16 physics series, where I am trying to help you to achieve your dream rank of 60 out of 60 in physics. If you are following us, if you are following from us from the beginning, then you know that we have already completed all the chapters of your second PU. Currently we are revising the chapters of first PU. We have completed the chapter revision for laws of motion. Today we are going to solve the previous year questions from laws of motion chapter, which is very important. Okay, solving previous year questions give you the perspective of thinking what type of questions is coming actually in KCET exam. Should we revise the entire chapter or we should revise the focused part? So based on the previous year questions, we curated the entire discussion of the chapter. Once the chapter discussion is over, then we solve the previous year questions. So in case there are some knowledge gap which may still be there, that will be completely cleared. So let's start with the laws of motion previous year questions today. But before going into that, I request you to join our WhatsApp group. The link is given in the description. There you will get the weekend KPL, KCET Premier League papers, and all the updates whenever we are doing a new session for new series. For example, we recently did PU2 midterm revision series. So if you want to get such updates that okay, PU2 revision series is coming, PU2 final revision is coming, or we are solving the blueprint questions for second PU. So whenever we are doing something new, you will get that update. So don't forget to join our WhatsApp channel if you have not yet, and also I request you to subscribe to our channel if you have not yet subscribed to. So let's start with question number 1. A body of mass 10 kg is kept on a horizontal surface. Okay, so mass of the body is 10 kg, it's kept on a horizontal surface. Okay, the coefficient of kinetic friction between the body and the surface is 0.5. So kinetic friction mu k is given 0.5. A horizontal force of 60 Newton is applied on the body. The resulting acceleration of the body. So they have said that the force applied on the body is 60 Newton. Okay, so they asked you find the resulting acceleration of the body. So first let us calculate what is the force of friction. So mg is equals to 10 times 10. Okay, so that is 100 Newton. And what is a normal force? Normal reaction force is 100 Newton again, right? Now they have not given the static friction at all, so we assume that the object is moving. In case they have given the static friction, then we would have calculated the static friction and whether the applied force is more than the static friction or not. Okay, so they have only given the kinetic friction, so assuming that the object is already moving, right? So what is the kinetic frictional force? Mu k times n, that is equals to 0.5 times 100, that is 50 Newton. Okay, so applied horizontal force is 60 Newton, the frictional force is 50 Newton. So what is the net force? The net force is basically force applied minus the force of friction, so that is equals to 60 minus 50, my mistake, 60 minus 50, that is equals to 10 Newton. So 10 Newton is the applied force. Now if resultant force, if the acceleration is a, then a will be m times a, so a will be equals to 10 divided by m. Now what is m? Mass of the object. Mass is again 10 kg, so it will be 1 meter per second square. Okay, so 1 meter per second square is the answer. So if you are solving these questions, be careful. maybe this problem might look a little difficult for you if you have not solved this kind of problems in your first PU. Okay, so but if you practice, this is very simple, easy question, 1 mark in your hand. Okay, that will create a difference between you and someone who is well prepared. Okay, so if you are thinking, okay sir, I will not do any first PU problems, first PU was hard, I skipped all the classes, I have not studied anything, I will just focus on second PU and I will try to score 45. You said 45 marks questions will come from second PU. Remember that one thing, second PU syllabus will have a lot of complex questions as well. So all the 45, even if you target all the 45, it will not be easy. Also last year, you know, there are many questions which were considered to be out of syllabus, and some of those questions, most of those questions are from second PU. So if you have ignored your first PU completely and somehow you received a question paper having out of syllabus questions, then there will be nothing to do for you, right? So don't ignore your first PU. Two masses of 5 kilograms and 3 kilograms are suspended with the help of massless inextensible strings. What is the meaning of inextensible? We always read this inextensible in JEE question paper, in KCET question paper, in NEET question paper as well. Inextensible means, suppose you hang something using a rubber band. What will happen? The rubber band will extend, right? So because it is a stretchable, it will extend. So we say this is an extensible, right? But if you hang using a normal thread, thread will also extend but very small amount, negligible amount. Okay, but if this is a inextensible cord, that means it will not even expand by even 1 millimeter. Okay, this is completely rigid, solid wire. The wire will not extend even if you hang something from it. Okay, so inextensible strings as shown in the figure. When whole system is going upwards with acceleration 2 meter per second square, the value of T1 is. So very interesting question. Okay, so they asked you to find the value of T1 when the entire system is moving upward with an acceleration of 2 meter per second square. Okay, so first of all, let us understand what are all the forces. So first force that acting on this is this downward force mg. Okay, now there is a tension force here T2 which is acting upward. The same, there is nothing is in between this wire. So if the tension here is T2, the tension should be T2 here as well. Okay, the tension here should also be T2. Okay, first we will consider the object A. Say this is object A, this is object B. Okay, first we will consider only this object, because there is a equilibrium for the objects individually. We can consider these two objects individually. Entire system is moving upward, right? So first we will consider the object A. So what are all the forces acting on this object A? First the force, tension force acting upward T2, and the weight acting downward mg, and the acceleration is A. Now if you have followed my class, there I said that whoever has the direction of acceleration, okay, between the forces, okay, 2, 3, 5, whatever the forces, whoever has the direction of acceleration in its favor, that is considered to be rich person. So here T2 is the rich force, Amir force, okay, and whoever has the opposite direction of acceleration, he is Garib force, poor force. So he is Garib, he is Amir. Okay, so what we have to do, we have to subtract Garib from Amir, or Amir minus Garib, equals to the acceleration times mass, ma. Okay, ma. So Amir minus Garib equals to ma, that is equals to ma. Amir minus Garib equals to ma, right? Fine. So what is T2 here? T2 you can see is nothing but mg plus ma. So what is m? The mass is 5 kilograms. You can take 5 common, you can write g is 10, and acceleration is given 12. Okay, so what I have done, I have taken m common, g plus a, right? So g is 10, a is 2, so 12, 5 12 is 60 Newton. This is the T2. Now we will apply the same concept of Amir and Garib for the object B. Okay, so for object B, this is for object A. For object B, again, what is the direction of acceleration? Direction of acceleration is again upward. Okay, we can individually treat them, that is the beauty of free body diagram. So we can treat them, and this force acting on this object is upwards, for acceleration is upwards. Now who is rich, who is poor? Okay, so T1 is rich, T2 is poor, right? T2, in this case here is T2, T2 is downward, right? So T2 is poor, T1 is rich. Okay, also here we have not only T2, here we also have the downward weight of this thing, right? So weight of this thing is also there, mg, okay, mbg. Now what are all the forces which are acting upward? Upward force is T1. So T1 should be equals to, T1 minus T2 plus mg. Both of them are acting downward, right? T2 is also downward, mg is also downward, both of the forces are downward. So T1 must be super rich. Even though two forces are acting downward, the acceleration is an upward direction. So T1 must be super rich person. So Amir minus Garib equals to ma. Okay, I made one mistake here. What mistake I made? I was considering object A, right? So for object A, the mass is 3 kilograms. Okay, so it will be 3 kilograms. 3 12 is 36. Okay, so that was a mistake. No one tell me anything, right? You are not observing carefully. So now what we have to do, we have to calculate the force T1. So T1 is basically equals to T2. T2 is 36. Okay. This entire thing goes to the other side and become positive. So mg, in this case m is 5, g is 10, ma is already there waiting, so it will be 5 times 2, so 36 plus 50 plus 10, so it is equals to 96 Newton. So T1 is 96 Newton. From the given option, we can say this will be 94.4 because instead of g equals to 10, they have tricked us by giving g equals to 9.8. Now if you try to solve the same problem using 9.8, the length of the problem will be bigger because you have to calculate all the decimals, add the decimals, multiply the decimals. But instead of doing that, if you use 10 and whatever is the closest value, that you can take. Since you have increased the value from 9.8 to 10, the correct answer will be slightly smaller than 96, which is 94.4. I hope you enjoyed this problem, and if you want more videos on Amir and Garib, you can mention that. I will try to solve few more normal problems, not KCET, maybe from some problem from NEET, some problem from JEE Mains. But if you want more such examples, do mention in the comment below. Now let's move on to question 3. A coin is placed on a rotating turntable, just slips if it is placed at a distance of 4 centimeters. So turntable means, so if you have seen a gramophone disc, okay, maybe in a cinema, maybe in a movie theater, so they rotate it like that, and there is a pin which plays the song, right? So rotating turntable means it is a table like that, the gramophone. Okay, the table itself is rotating. Okay, so the table is rotating and you place a coin. So basically you place a coin on top of a gramophone, that you can consider. Okay, so there is a coin. Okay, the turntable is rotating. If the angular velocity of the turntable is double, at what distance it will slip? So when the distance is 4 centimeter, it just slips. Okay, so just slips means at this distance the centripetal force required is more than that of the force which is keeping it static, okay, the force of friction. Okay, the force of friction which is trying to keep it static, otherwise it will slip outward, it will slip in this direction. So force of friction generally acts in this direction to make it steady. Okay, so that force of friction will remain constant no matter where you place it. Okay, that force of friction is independent of the distance, but the centripetal force Fc, which is equals to m omega square r, okay, it will be varying from object to object. Now first case where r is 4 centimeter, what was the required centripetal force? So m omega square times 4. This is the first case, mc1. Now in the second case, okay, fc2, what you have done, you have doubled the angular velocity. Okay, angular velocity is doubled, and now you are trying to find at what r it will be at a static condition. So this condition should be followed, m omega square r, mv square by r, or m omega square r. If you are applying m omega square r, the problem is easier. Now what you have to do, you have to divide fc1 by fc2. Okay, they are equal, right? They are equal, because no matter where you keep this coin, the centripetal force required is coming from the force of friction, so they should be equal. Or you can write fc1 equals to fc2, simple. Okay, so now put the values, m omega square times 4 equals to m 4 omega square r. Okay, 2 omega whole square is 4 omega square. So m omega square cancels, 4 cancels, so only 1 is left. So from here you can write r is equal to 1. Okay, so r is equal to 1 centimeter. So 1 centimeter is the answer to this question. Okay, now let's move on to the next question. 4. One end of a string of length L is connected to a particle of mass m and the other to a small peg on a smooth horizontal table. Okay, if the particle moves in a circle with the speed v, the net force on the particle directed towards the center is T is the tension in the string. So there are different cases. Okay, so one string is tied, okay, on the center of the string, center of the table, and then smooth horizontal table if the particle moves in a circle with the speed v. Okay, so the particle is moving with the circle with the speed v. Okay, so they asked you what is the force acting on it. So when this is completing a circular motion, we know that the only force acting on this is actually equals to mv square by r, right? So the only force that acting on this is mv square by, in this case, L. Okay. Now, as I said during my class, if you have followed my class, I said that this force has to be provided by someone. Okay, centripetal force is nothing that comes like a natural force. Okay, it is not a fundamental force. It is a force that has to be provided by some other force. Which force can provide that force? Only force acting in this case is the tension of the string. Okay, so only force that acts on this object is tension. Okay, so tension should be equals to mv square L. So the answer will be either mv square by L or tension T. In this case, mv square by L is nowhere given. So only possible option is T. Okay, this is a conceptual question. Okay, even though somewhat mathematics is related, but this is mostly a conceptual question. If you have understood the question, then only you will be able to answer this question. Now, question number 5. Okay, I solved this question during my class. I am going to solve it again. An object with mass 5 kg is acted upon by a force of F is equal to minus 3I plus 4J Newton. If its initial velocity at t equals to 0 is v equals to 6I minus 12j meter per second, the time at which it will only have just a velocity along y axis. So it will only have a velocity along y axis. That means its velocity along x axis will be 0. So velocity along x axis will be 0. Okay. Now let us see what is the problem talks about. There are two components of force. One component is along x axis, one component is along y axis. Similarly, velocity will also have a component along x axis, velocity will also have a component along y axis. Now the condition that we are trying to find, that we are interested is that they are saying that where the velocity along y axis will only remain, nothing else. So velocity along x axis will be 0. To solve this problem, we need to consider all the components of force, all the components of velocity only along x axis. Okay, because that we have to find and then we have to compare it to 0, right? So how can we do that? What is the component of force along x axis? Component of force along x axis is minus 3. Negative force means this is it is retarding force, right? Now what is the acceleration along x axis? Acceleration along x axis, we know that from second law of motion, it is F by m or minus 3 divided by 5, okay, and negative acceleration means it's a retardation, right? Now what is the initial velocity along x axis? Initial velocity along x axis was 6, okay. So I means x component, j means y component. I hope you are familiar with that. Now the final velocity along x axis should be 0, right? Then only it will have a component along y axis alone. So final velocity is 0. We know that v is equal to u minus plus at. Okay, since we are already considering the sign, we don't need to add negative here. So ux equals to minus at, or t equals to ux by minus a. What is ux? Ux is 6. What is minus a? Minus of this, so it will become positive, 3 by 5. So it will become 2. So it will become 2 times 5, right? So 2 times 5 means 10 second. After 10 second, it will only have component at 10 second basically. At 10th second, it will only have a component along y axis only. Okay. Now let's move on. A man weighing 60 kg in a lift moving down with an acceleration of 1.8 meter per second. The force exerted by the floor on him is. So we have solved this problem. We will be solving this problem again. Suppose there is a person standing on the lift. Okay, what is the weight? Weigh 60 kg. 60 kg weigh means actually mass is 60 kg. Okay, and its weight will be 60 times 10, that is 600 Newton. Okay, so its mass will be 600 Newton. The lift is accelerated with 1.8 meter per second, but it is accelerating downward. Okay, so what will be the force exerted by the floor on him? So the force exerted by the floor on him, say N, normal reaction force, right? So what we have to do, we have to calculate this N. Now how can we calculate? I told you the direction of acceleration acts in the richer force, Amir. So who is Amir here? Acceleration downward, weight is also downward. So weight is Amir. Okay, so Amir minus Garib. Garib is upward force here. So N, that should be equals to Ma. Okay, so 600 minus N equals to M is 60 and acceleration is 1.8. So N is equals to 600 minus 60 times 1.8. Now what we can do, one thing here, and that will be easier actually, that instead of multiplying 10 here directly, we keep it as G, mg, right? So let's keep it as G. Why, you will see in a while. So it will be 60 G. Okay, 60 G 60 G. Now we take 60 common. Now let's write G as its original value 9.8 minus 1.8. Okay, why? Because if you do the subtraction, it will be easier for us, right? And we don't want to do hard work. We are lazy person, right? So 48, 480 Newton. So correct answer is 480 Newton, right? So if you solve it, it is definitely not 0 unless it is 9.8 meter per second falling, freely falling, then obviously the force exerted by the ground will be 0. Okay, so this is a very neat trick of Amir and Garib. If you practice few problems, you will be master in that, and you will never have any problem when the system is accelerating. Okay, a block rests on a rough inclined plane making an angle 30 degrees with the horizontal. The coefficient of static friction between the block and the plane is 0.8. If the frictional force on the block is 10 Newton, the mass of the block is. Okay, so you have to understand that here when the block is resting on a inclined plane, okay, the angle of the incline is 30 degrees. Will the block move or not? This is a very interesting critical question. Okay, I hope you will be able to understand this question. First of all, here I said first calculate tan theta, and if you remember the value of tan 30 degrees, it will be around 0.57. Okay, and this is clearly less than that of the static friction, coefficient of static friction 0.8. So this is less than that of the static friction, so the block will not move. Okay, so when the block is not moving, the friction, the force of friction is actually whatever force that is acting in the forward direction. The same amount of force will act in the backward direction as force of friction. Okay, so here what force is acting? Downward force is mg. This component is mg cos theta. This is mg sin theta, and this equals to the force of friction here. So mg sin theta is equals to force of friction. Why? Because you don't need to calculate the normal component to calculate force of friction. Normal component to calculate force of friction is only when the object is either moving or it is at the maximum limit. Okay, otherwise that is object is just starts to move. In that case only you take normal component, otherwise you don't need to take the normal component. So in this case mg sin theta equals to 10. Okay, so what is m is equals to m times g is 10, sin theta sin 30, sin 30 is half, so 10, or m equals to 2 kg, 2 kilograms. Okay, so it is 2 kg. Okay, I hope you understand this question. This is little bit fundamental question. If you lack fundamental knowledge of friction, maybe you will not be able to understand this question at this stage, but for that I will request you to revise the chapter friction once more. Okay, what is the basic difference between kinetic and static friction? Also you should remember that the static friction can vary from 0 to maximum possible value. The maximum possible value is mu times n. That is not the always frictional value. Okay, now let's move on to the next question. A body of mass 50 kilogram is suspended using a spring. Okay, again I think it's a lift problem. So as you can see, there are a lot of lift problem is coming. So a body of mass 50 kg is suspended using a spring balance inside a lift. At rest, if the lift starts falling freely, okay, the reading of the spring balance will be now the weight of the object is mg, okay, and whatever the reaction force, normal reaction force, that is being measured by the spring balance. Okay, and when the lift falls freely, okay, we discussed this during our lecture that suppose the normal force is n, Okay, so n minus mg, mg minus n. Mg is Amir here, n is in the opposite direction, so it will be Garib. Mg minus n equals to ma, that is another g here falling freely, so n equals to mg minus mg equals to 0. So the reading of the spring balance will be 0. Okay, so reading of the spring balance will be 0. Now if they ask you if it is a normal balance, then it will not change. Okay, but for spring balance which is dependent on the weight, okay, it will change. Okay, not for normal balance. Now the maximum acceleration of the train in which a 50 kg box lying on its floor will remain stationary given, it is not with, it is will. Okay, will remain stationary given coefficient of static friction between the box and the train's floor is 0.3. Take the g equals to 10 meter per second square. So there is a train. Suppose there is a train, okay, where open bogie is there. Okay, okay, here Shah Rukh Khan and Salman Khan are fighting. They are fighting the villains. Okay, there is an open space. I know what movie I am talking about. If you know the name, tell me. Okay, so some blast has happened and this box is lying on this floor. Okay, now what it says that what is the maximum speed with which the train can move such that the box will remain stationary. Okay, the maximum acceleration with the train. Suppose the maximum acceleration of the train is a. Okay, now what is the force of friction acting on this? So this is mg, this is normal reaction force. Okay, so normal reaction force equals to mg. So force of friction, static force of friction is equals to mu s times n. And what force acting on this direction? If the acceleration of the train is a, then the force acting on this direction is ma. So let's put this value. So in equilibrium condition, in the case of equilibrium, mu s n, that is force of friction, should be equals to ma, or mu s times mg, n is equals to mg here, should be equals to ma, m cancels. So maximum acceleration with which the train can move is nothing but mu s g. What is mu? Mu is 0.3 and g is 10. So it can move 3 meter per second square. That is the maximum acceleration with which the train can move so that the box does not slip. Okay, so correct answer is option B. Okay, 3 meter per second square. Now a stone of mass 0.5 kilogram is thrown vertically upwards. What is the direction and magnitude of the net force on the stone during its upward motion? Okay, so you throw a stone upward direction. Okay, what is the direction and magnitude of net force acting on this object? So remember that always force, net force that acts on an object whenever you throw it up is downwards. Okay, unless it is a rocket where you are supplying enough fuel to overcome that gravitational force, so the net force is upward direction. Okay, otherwise for any object that you throw upwards, the net force will always act downward direction, including the gravitational force which is majorly acting on this object, and there is also a viscous force, okay, which is acting again downward direction, opposite to the motion. Okay, in that case viscous force always acts opposite to the motion, similar to friction force. So during its upward journey the net force will always be acting downward. That's why after some time it will stop and then again it will start falling. So what is the force that acts is always equals to mg. Okay, m is given 0.05. okay, and let assume g is 10 here, we will take the closest value, so it will be equals to 0.5 Newton. So 0.5 Newton force acting vertically downwards. So from this we can say that correct answer will be 0.49 Newton vertically downward. Direction is more important in this problem. This value you can calculate. Okay, so mass is given. Okay, and so you can calculate the force 0.5 Newton obviously. So 0.5 Newton or 0.49 Newton if you use 9.8. So 0.49 Newton vertically downwards. This is very, very important. Right? Now next question. An aeroplane executes a horizontal loop at a speed of 720 km per hour with its wings banked at an angle 45 degrees. What is the radius of the loop? Now this is a problem based on formula. So before applying the formula, what we have to do, we have to find the velocity in a meter per second. So 720, what is the velocity? Initial velocity is 720 km per hour. To convert it into meter per second, we have to apply a factor of 5 by 18. If you are wondering how I achieved this factor, you can check how can you convert kilometer per hour to meter per second. Okay, kilometer is 1000 meter, hour is in division, that will be 60 into 60. So using that you can convert it into meter per second. Okay, so 9 360 40, so it is 200 meter per second. Now there is a formula of banking, okay, that I have not done during my class. So I am telling you, if there is a car or anything, okay, in this case there is an aeroplane, okay, if it is taking a bank, okay, when maneuvering, okay, the relationship between the banking angle and the radius is given by tan theta equals to Rg by V square. Okay, tan theta equals to V square by Rg. Tan theta equals to V square by Rg. It is a very old formula, currently not explicitly given in your textbook, but you can revise it. It's simple formula. If you know, you can find the radius. Radius r is given by V square by G tan theta. Okay, so what is V square? V square is 200 whole square and G is 10. Tan 45 degrees obviously 1, so it will be 4 1 2 3 4 zeros, 2 zeros, square means double of that, divided by 0, 1 0 cancel. So 4000 meters, 4000 meters means 4 kilometers. Okay, so the correct answer is 4 kilometers. Okay, something a new problem. Now a person is driving a vehicle at uniform speed of 5 meter per second, okay, on a level curved track of radius 5 meter. So uniform speed of 5 meter per second, curved track of radius 5 meter. The coefficient of static friction between the tires and the road is 0.1. Will the person slip while taking the turn with the same speed? So what is the force, which force is providing the required centripetal force here? The force of friction is providing the required centripetal force. So what is the centripetal force here? mv square by r. And what is the frictional force? Frictional force is mu mg. Okay, so now m cancels. So V square equals to mu Rg. Let's put the value. Mu is 0.1. Okay, R is 5 meter. G is 10. So it will be 5. So V square equals to 5. If V square is equals to 5, then the car will just start to slip, or we can say it is not slipping. Okay. But if V square value is greater than that of 5, then definitely the car will slip. This is the maximum possible value, right? This is the maximum possible value with that car can move. Okay, there is a formula. While during our class we used the maximum possible value to solve this problem. But how we achieve that formula? We achieve that formula by comparing the required centripetal force with the frictional force which is providing that force. So we can say that the person will slip if v square equals to v square is greater than 5. Right. Now tell me, in this case, in this problem, if the question was asked differently, because the speed is given here, right? So will the car will slip or not? So mention the answer in the comment below, whether the car will slip or not. Okay, I am leaving it to you. You mention in the comment below that what do you think in this case, the car will slip or not. Now next question. A block is kept on a frictionless inclined surface with an angle of inclination alpha. The incline is given an acceleration of a to keep the block stationary, then a is equals to, so a block is kept on an incline. Okay, angle of inclination is alpha. Okay, now the incline is given an acceleration a. Now let us consider all the forces that acting on this object. So first of all, obviously mg is acting downward. There will be a component of mg acting in this direction. Okay, there will be a reaction force here, normal reaction force. There will be a component of mg here, mg sin theta. If this is alpha, this will be alpha, so this will be mg sin alpha. This is actually easy problem, mg sin alpha. Now also there will be a force because this object is accelerating, so that means there will be a force in this direction as well. Okay, so what is this force? If the acceleration is a, then this will be ma, this force will be ma, and there will be a component in this direction of this force. This force is a, means this angle will be alpha. Okay, so this angle will be alpha in this case now, because this is alpha, that you can take, this is parallel line, this is the intersection, so this angle is alpha, means this angle will also be alpha. Okay, so what is the component of ma along this direction? Ma cos alpha. Okay, you can take another component of this ma along this direction as well, ma sin alpha. Now all the components along horizontal and vertical has to balance each other, right? So if you consider the this direction balancing along the incline, okay, you can take this direction, but that will not give you anything. This entire force will be balanced by the normal reaction force, right? But this force will only be balanced by this ma cos alpha component. So mg sin alpha has to be equals to ma cos alpha, right? This is due to the force of external acceleration. Okay, this external acceleration, some external force is acting on it, so because of that there is an acceleration, so that acceleration is causing a force. Okay, so that force component along the incline, that this should be upward direction, this should be downward direction, and in case of equilibrium they should balance each other. So we can say that a equals to g sin alpha by cos alpha. Okay, so from here we can write a equals to g tan alpha. So the acceleration required here is g tan alpha. This is tan alpha. Okay, so correct answer is option B. Okay, now the reaction of the floor on an object placed on the floor of an elevator is maximum when the elevator. So we have an object placed on the floor of an elevator. Okay, the reaction force on the object, so reaction force when it will be maximum. The reaction force will be maximum. From the problems that we have solved today, we can say that the reaction force will be maximum when it is accelerating upward. When the elevator is moving upward with an acceleration, the reaction force will be maximum. So acceleration upwards when the reaction force will be maximum. When the reaction force will be minimum, Okay, so cable snaps and falls towards the earth. So in that case, reaction force will be 0. Okay, that is the minimum value. Right now, last question. A mass of 6 kg is suspended by a rope of length 2 meter from a ceiling. Okay, so I solved this problem during my class. Okay, and force of 50 Newton in the horizontal direction is applied from the midpoint. So the diagram would be like this. So this is the 50 Newton force you are applying on the rope, and the mass hanging from this is 6 kg, right? So this is the weight mg, okay, and 50 Newton. You have to calculate the angle made by the wire with the horizontal, calculate the angle made by the rope with the vertical in equilibrium. Now what are all the forces? If you take this 50 Newton force, then someone has to balance this force if it is in equilibrium. This also someone has to balance this mg force. Now who will balance everything? Let's take this tension of the rope is T. If the tension of the rope at this point is T, then it will have two components. One is along this direction, okay, and another one is in this direction. So this angle is theta, so this will be T cos theta, adjacent component, and this will be T sin theta. Right now, T cos theta will balance this mg force, right? So T cos theta will be equals to mg. So what is mg? Don't worry about the values yet, but you can put m is equals to 6 kg, g is equals to 10, so it will be 60. Okay, and what is T sin theta? T sin theta has to balance this force 50 Newton, so it will be equals to 50. Okay, now you divide T sin theta by T cos theta, then you will get tan theta. T will cancel. Okay, so you will get, it will be 50 by 60, right? T sin theta divided by T cos theta, so it will be 5 by 6. Okay, so here if you take the tan inverse, you will get almost equals to 39.8. okay, 39.8 degrees, that is equals to almost close to 40 degrees. Okay, if this same question comes in your exam, then they will give you the values such that you can find some good value. Okay, this is not exactly a good value because 5 by 6 is not from some known value of angle theta, but if you have solved this question again, you can answer it, but in final exam you can trust me, the values will be given much better than whatever is given here. Now we have reached the end of this lecture, so if you have any doubt, any questions, don't forget to mention that in the comment, and if you are watching this video for the first time, don't forget to subscribe to our channel and share it with your friends. I will be back with a new chapter tomorrow. Till then, bye.